Okay, today's lesson is on density. Okay, the definition of density is the measure of how much mass is contained in a given volume. The formula to calculate density is mass divided by volume. So here in this figure, we're comparing densities. Which item has the greater density? Well, obviously, to get this, you'd think, yeah, the bowling ball, and that is true. Since the bowling ball has a greater mass, it has a greater density, even though both balls have the actual same volume. The bowling ball is denser. In other words, it has more mass per same unit of volume. So let's talk about units and how we measure density. Okay, it's 2 units actually. When you have a unit for density, you have 2 units. Okay, because you're giving you have 2 other measurements. You have the mass and the volume. An object's density is expressed as a combination of 2 units. Okay, so some common units you might see for density is grams, that's the mass, per cubic centimeters, that's the volume. Okay, another way of a unit of density is grams, that's the mass, per milliliter, which is the volume. Okay, so these are 2 ways that we can express density as far as the units go. Okay, so we're going to practice some problems. Say we have a wood block with a volume of 125 cubic centimeters and a mass of 57 grams. Okay, so if we take our formula for density, and sometimes it's like that, mass over volume. We take that formula and you take 57 and divide it by 125, you get, well, let's go back and put it in the calculator. So we get 0.456 grams per cubic centimeters. So that is the density of this object, this wooden block here. Okay, let's do another one. Okay, what if the density of a liquid has a mass of 45 grams and a volume of 48 milliliters? If we put that into the calculator, 45 divided by 48, we get 0.9375, and that would be grams per milliliter, and we could probably round that 0.938. Okay, so that's another example. Okay, let's talk about some density of some common substances. The density of a substance is the blank for all samples of that substance. It's the same. If you have pure gold, okay, and you had a big cube of it, like that, or you had a little tiny nugget like that, the mass is different of both of them, the volume is different on both of them, but the density is the same because it's the same substance. Okay, an object will float If it is blank, then a surrounding liquid. An object will float if it is blank, then a surrounding liquid. Less dense. Okay, now, examples. Oil and water. Oil always floats on water because the liquid oil is actually less dense than the water around it. So here, how do you use density to determine whether a metal bar is pure gold? Well, here's some densities of some substances. Okay, if the bar of gold has a density that is greater than or less than 19.3, it's not going to be pure gold. Okay, so an object with a density of 0.7 grams per cubic centimeters will float in water because it is less dense than water. The density of water is 1.0000 grams per centimeter. Okay, that's what density is based off, is water has a density of 1 gram per cubic centimeter, or 1 gram per milliliter. That's the same thing. Okay, so if we look at this chart here that was in your practice problem, it's a list of different solids, liquids, and gases and their density. And if you look at it closely, you will notice, obviously, that gases have the lowest density. These are all in grams per cubic centimeter. Liquids have an even little bit higher density, and the solids, most of them have the highest density. Okay, and that kind of makes sense because gases are less dense than liquids in general than in solids. So what you were to do is to use the table here to give an example of a solid object that has a low density and a small volume. So a low density with a small volume. So probably they all have the same volume. So you would go through and find ones that have a low density. So for instance, any of the gases like hydrogen or helium or ammonia, those would be some example of low densities and small volumes. Low density and a large volume. Low density in a large volume, again, that would be the gases and some of the liquids. High density and small volume. Any of the solids, the one that has the highest density on this list is platinum at 21.5 grams per cubic centimeter. And high density at a large volume, that would mean the same thing. So gold, platinum, etc. Okay, number 2A, say name 2 solids that are less dense than pure water. Less dense than pure water. Well, pure water is 1. So you go over and look at the solids list, and there's several: balsa wood, ice, wax, etc. Part B, name 2 liquids that are more dense than water. Well, mercury is a very heavy, dense liquid. And C, name 2 gases that are more dense than carbon dioxide. Well, CO2 is 0.00198. So more dense than that. Well, the only one on here would be chlorine. Would be the only one on here that would be that way. That's more dense, a gas that's more dense than carbon dioxide. Okay, if we turn the page and look at the next problem, it says one lead cube has an edge 1 centimeter long. A second lead cube has an edge 2 centimeters long. Okay, so it's saying right here, guys, that it's a cube. A cube means it's the same length, width, and height. Okay, so let's calculate the volume. Well, this first cube is 1 times 1 times 1, so it's 1 cubic centimeter. This cube, this lead cube, is 2 times 2 times 2, which is 8 cubic centimeters is the volume of that one. The volume of that one. Okay, and what properties are the two cubes different? Where they're obviously, since they're both lead, their mass is going to be different, and both of them, their volume is going to be different. Obviously, it's different. What are their properties are the same? Well, since they're both lead, their density will be the same. Okay, so we showed the work to calculate the volume of both cubes. Both cubes are made of lead. Use the density of lead from the table on the first page and the volumes of lead that you calculated above to find the mass of each cube. So this is where we get just a tiny bit more difficult in these density problems, because we know from the chart on the first page that lead has a density of 11.3 grams per cubic centimeter. Okay, we know that. All right, now we know the volume of the two cubes because we calculated it above. Now what they're asking is, what is the mass? Okay, we know that density is mass over volume. Okay, now to find the mass, we simply take this algebraic equation and get m by itself. Okay, if we get m by itself, then we can calculate what the mass is. So how about if we multiply both sides by v here, then these v's cancel. So mass is equal to density times the volume. Okay? All right, so let's solve for the first cube. Mass is equal to density times the volume, which was 1 gram per cubic centimeter. Okay, so 11.3 times 1 is 3 grams. Okay, so that's the mass of the first cube. Now the second cube is 11.3 times, the volume was 8. The volume was 8. Oh, I did this, I put grams there, I should have, and then these would have canceled there. The volume was 8 cubic centimeters. So 11.3 times 8 is equal to 90.4 grams. Okay, so they both have the same density, different volumes, different masses, but they have the same density, so they're the same substance. Okay, now let's go to the bottom of the page to problem number 4. Okay, again, you're going to be using your tables on the front of the different densities of different substances. So they say you're given equal masses of lead, aluminum, platinum, and brass. You're supposed to arrange the masses in order of increasing volume. Okay, so what you do is you find out the density of all of these from the table. Okay, and you write it down. And they give you a little hint there. Let's say you have equal masses of all 4. Okay, so let's give all 4 an easy mass of, say, 1. And to solve for volume, you take your formula, density equals mass over volume, and you rearrange it to get volume by itself, and you come up with V equals M over D. So if we put the 1 for the mass for each of those, and then underneath it put the density of each of these, then we can solve for volume for each of these. So if we take 1 and divide it by 11.3 for lead, we get 0.09 cubic centimeters. Okay, if we take aluminum, 1 divided by 2.7, and the volume is 0.037 cubic centimeters. Same for platinum, 1 over 21.5, and we get 0.047. Is that right? 1 divided by 21.5. That might not be right. 1 divided by 21.5. Yeah, that's right. 0.047. And then if we do the same for brass, then we get 1 divided by 8.5, and you get 0.118. Okay, so then we can put them in order of the volume. So the smallest volume is the aluminum. And then we go to the next smallest is platinum. The next smallest volume is lead. 1, 2, 3. And then the next smallest volume is going to be brass, which is 4 here. Okay, so that's just taking your equation for density and rearranging it to solve for something else. Okay, see how you do on the rest of these problems.